dimensional analysis if some of the units are squared or cubed. So something like 3 feet cubed, that's a volume, or something like 27 meters squared, like an area. You can use the same idea we've been using for dimensional analysis. We need to cancel out feet. What are we going to convert it to? Let's go from feet cubed into meters cubed. And then from square meters, we can go to maybe inches squared down here. So start with 3 feet cubed. And the problem is the cube throws off the conversion factor. So if I'm trying to go to meters from feet, I know that 1 foot is 0.3048 meters. But I don't know if 1 foot cubed is 0.3048 meters cubed. Or actually, I do know. That's not right. It's not the same number if the power on the unit is higher. Because if you think about volume and a box, if each side is 1 foot, this is a box whose volume is 1 by 1 by 1 feet cubed. 1 times 1 times 1. That's how you get the volume of this box. But if I write that as an identical measurement, 0.3048 meters, 0.3048 meters, 0.3048 meters, I see that to calculate the volume of this box, I got to multiply this times this times this. So really, I need to cube this. I need to take the original conversion factor that I had and cube it in order to figure out what the conversion factor really is for 1 foot cubed into meters cubed. That means cube the unit and the number and the unit. But you don't have to do it separately out over here like this. The way I would do it is write it in the fraction form. So 1 foot is 0.3048 meters. And now I can see, if I imagine that that's over 1 feet, well, to the first power, it's really just feet down here, are not going to cancel feet cubed. You know, if you divide x cubed by x, you end up with x squared. It just takes away one of the x's. So if I do the math right now without fixing this, I'm going to end up with nonsense. So to fix it, you cube the entire conversion factor. And that cubed goes to that number, it goes to that unit, it goes to that number, and it goes to that unit. So another way to write this is 0.3048 cubed meters cubed over 1 cubed feet cubed. You don't need to rewrite this every time you do a problem. I'm just trying to show you explicitly that the cubed that was out here goes to everything. Now, feet cubed and feet cubed will cancel, and I'll be left with meters cubed. And I just need to calculate the answer. So 3 times 0.3048, and don't forget to cube it. Hit enter, and it's 0.085 meters cubed. So let me show you what that would look like without doing all the rewriting for this other one. I would do 27 meters squared, and I'm trying to get to inches. I could go to centimeters, and then from centimeters I could go to inches. So I know that in 1 meter there's 100 centimeters. And I know that, oh wait, it's not going to cancel, so I've got to square everything. Now meters squared will cancel with meters squared. Centimeters, I can go 1 inch is 2.54 centimeters. Square everything. Now I would go type this in the calculator. 27 times 100 squared times, or divided by, because the 2.54 is on the bottom, 2.54 squared. What do I get? 41,850. Stop for a second and do a sanity check. Does that make sense? 27 meters squared is very big. That's a square. Like, draw a square on the ground, 27 meters on one side and 27 meters on the other side. That's going to be a whole bunch of inches squared. A square inch is a square that's an inch on each side. So yeah, it makes sense that I got a big number. Same thing up here in the previous problem. It makes sense that this number is smaller because a meter is a bigger unit of measurement. So 3 feet cubed shouldn't be very many meters cubed, and it's not.